Hello student, now I am ready with the fourth class of electrostat. We are discussing the properties of electric charge and how to calculate force acting on point charges. In my third class, the video is available with you. In the third class, we discuss how to calculate force acting on point charges. Few questions discussed. The last one is this: 4 point charges are kept at the corners of a square. How to calculate force acting on any point charge at one corner? The whole procedure explained. In that case, one interesting point was there, as force because of this charge and force because of this charge acting on this one same, say this is F1 as well, this is also F1, their resultant passes to the middle. So their resultant calculated, resultant for all F1, actually 2 F1 present, so that gives us root 2 F1. That root 2 F1 passing to the middle because these two equal and it is in the same direction with F2, so they are added directly. Now I am going to discuss a situation, by chance it is not the same, all the charges, then how to do the calculation, then only the actual concept comes into play. Normally in school syllabus, we are actually looking for competitive exam. In school syllabus, these type of questions are available. Now, if you look at those kind of situation where charges are different than how to handle, so look at this idea. Say for example, here one charge presents a Q, here one charge presents a twice Q, here one charge presents thrice Q, and the charge at this corner, say for example root 2Q. I am intentionally making all the charges different. So as usual, as discussed, you should be ready with pen and paper before you come to my video class. Now you should write the question first. Question is, 4 point charges are kept at the corners of a square of side L. Their charges are as shown, meaning in this corner it is Q charge, here it is twice Q, here it is root 3Q, here it is root 2Q. In this case, all the charges different. My question is, what is the force acting on the point charge small q? I hope question is clear. Now I am calculating force acting on point charge small q. How to do? Procedure same. This q, because of the twice q here, getting a repulsion in this side. I am writing it is F because of 2. Because of this thrice q, this q getting a repulsion in this side, I am writing F because of thrice q. And because of this root 2q, we know this distance is root 12. In the last problem, that same root 12 is used here. Now this distance is root 12. This root 2q will repel this q. The resultant of all this required force in this side, I am writing F because of root 2. Question is almost similar to this. Difference is F because of thrice q and F because of twice q acting here. F because of twice q and F because of root 2q and F because of thrice q, they are not equal. In the previous case, F1 from this side and F1 from this side equal, so they are resultant calculated, they are resultant passing to the middle, so we are adding with F2 directly. Now what is the force in this side and what is the force in this side? If you calculate, it is force because of the charge twice q acting on this q. It is 1 by 4 pi epsilon naught because no medium mentioned. So I am going to consider that it is either kept in air or in vacuum. It is q into twice q, q charge here, twice q here, divided by the distance of separation, it is L because square. So force is twice q square by 4 pi epsilon naught L square. If you write force because of thrice q, meaning because of this thrice q, it will be in this side because it is repulsion. Here it is in the same way, 1 by 4 pi epsilon naught q into thrice q divided by the distance L square. So it becomes 3q square by 4 pi epsilon naught L square. So look at force because of twice q and force because of thrice q not same. If not same, their result will not pass to the middle. So this idea of doing calculation simply fails. How to do? I am coming to it. F because of root 2q, only value I am writing, direction drawn. It is 1 by 4 pi epsilon naught q and root 2q. So q multiplied by root 2q divided by this distance root 2l. Don't forget to square it. So it becomes root 2 q square by 4 pi epsilon naught then twice L square. Now this force acting through the diagonal of the square, thrice q and twice q, their direction known. Only difficulty is they are not lying, their resulted not lying to the middle because f because of thrice q and f because of twice q simply are not equal. So we cannot find resultant of these two. The best idea is better you break this force because of root 2q in two parts. As total angle is 90 degree, this angle 45 degree. If any other kind of drawing, then angle will be given directly or indirectly. So if you break f because of root 2q, a part will be in this side, a part will be in this side. You know any vector can be broken into two parts. So there will be a part in this side. If you write part in this side, I am writing here, it is f because of root 2q cos of 45. And part of this in this side, I am writing here, it is f because of root 2q then sine of 45. You know, if any vector a present, if it makes an angle theta, a part in this side is a cos theta and a part in this side is a sin theta. So this is called resolution of vector. So vector a can be broken into two parts. So similarly vector is this f because of root 2q, force is a vector, this angle 45 degree because of the drawing, a part f because of root 2q cos of 45 and the other one is f because of root 2q sine of 45. So total force in this side and total force in this side, let me calculate separately. Yeah. Now I am going to write in vector force in this side. I am writing force in this side. I am writing 1 f because of twice q already present in this side and other one is f because of root 2q cos of 45. F because of twice q value we know, this one, what is that? Twice q square by 4 pi epsilon naught L square. F because of root 2q also written here, this one, meaning simplified is this. So let me write root 2q square by 4 pi epsilon naught into twice L square cos of 45. You know cos of 45 or sine of 45 having same value 1 by root 2. So this root 2 and this root 2 goes cancel. Clear? So together I am going to write q square common, 4 pi epsilon naught L square also common. From here 1 2. Here root 2 and root 2 goes cancel. From here 1 by 2. This force in this direction. In vector, in the direction opposite of x-axis is minus I cap. I am writing in vector now. You can write in the direction opposite to x-axis also. If you simplify, then it becomes, if you take LCM, it is 5 by 2. So it becomes 5q square by 8 pi epsilon naught L square minus of I cap. I have no difficulty in that. At the time of doing calculation, just force because of twice q and the part of the force because of root 2q in this side together added, it is q square by 4 pi epsilon naught L square common. At the time of doing calculation, 2 remaining free here and 1 by root 2 together, it is after LCM 5 by 2, so I am writing 5 by 2, so already 4 present, so it is 8. Clear? This is the force along x-axis, of course not on x-axis, in the opposite direction of x-axis. If you write force along y-axis, then already along y-axis this force present, what is that? This value. It is F because of thrice q plus a part in this side, what is that? F because of root 2q sine of 45. So these two force in the same side, so you can add directly. If you put values accordingly, values of root force because of thrice q available, meaning this one, and root 2q sine of 45 also available. If you put the value, it will be in the same way 7q square by 8 pi epsilon naught L square. It is now along y-axis, so j cap. So in this side total force and in this side total force calculated. Be careful, I am writing the symbol only, values available here. Force because of thrice q is this value, and force because of root 2q is this one. Cos of 45 or sine of 45 value you know, sine 45. Simplification in the same way. Here it is, if you put value here, it is not 2, it will be 3.5. So it becomes 7 by 2. So I am writing directly 7 by 8 because already 2 present here. So this is the force individually along x-axis and along y-axis. Now with this we can find the total force. How? Just look at that. Now we are getting a situation, this charge q, meaning this one I am drawing, my original square is this, here it is twice q, here it is thrice q, here it is root 2q. Now force in this side is 5q square by 8 pi epsilon naught L square, and force in this side is 7q square by 8 pi epsilon naught L square. Clear? So I am going to write the total force. So I am writing total force. We can write in two ways. We can write in magnitude, we can write in direction also together. So if you write in vector, it is q square by 8 pi epsilon naught L square common. It is minus 5 I cap. In this side 7 j cap. Minus I cap meaning in the opposite direction of x-axis, j meaning along y-axis, just upward and horizontally left side direction shown. So this is the result if you are interested in writing in vector. If you want to write magnitude of force only, then q square by 8 pi epsilon naught L square, magnitude of this one is under root minus 5 square plus 7 square. Minus 5 square meaning 25, 7 square meaning 49. So you can find the magnitude easily. So we can write in two ways. If you write in magnitude, this is the answer. If you write in vector, this is the answer. Anyway, if different kind of point charge is available, then method may not be simple as we discuss, may not be as simple as we discussed in the last class. In that case, different charges giving us different force. So like this one, force in this side and force in this side not equal, so you cannot find the resultant easily. In that case, their resultant we cannot find. Instead of that, we have to break the middle one into two parts and then we should do the calculation. So this is the way how to proceed. I'm sure you get the idea how to calculate force acting on a point charge like this. So if charges are different, be careful in adding. Yeah? In some case, factors are added directly. in some case vector broken into components and then added. It depends on the situation. I hope the explanation now becomes clear to you. Clear? Okay, I am writing another question to you now. Clear? As you should be always ready with pen and paper, I am going to explain the question. First, you should write the question. Now the question is, 2 point charges, you write first, 2 point charges are kept separated by a distance of 1 meter. 2 point charges are kept separated by a distance of 1 meter. Find the least possible force between them. Find the least possible force between them. So what is the question? Written 2 point charge present. They are separated by a distance of 1 meter. This is also written. In the question, nowhere value of the two charges given. Only thing is, you have to find the minimum possible force between them. Now, quite interesting question. You have to find minimum force between them, but the value of the charge is not given. First of all, as no medium mentioned, I am going to consider they are available. They are placed in air or in vacuum. So if charge in them are respectively Q and Q, force will be like this. Say if Q1 and Q2, then it is Q1, Q2 like this. Whether attraction or repulsion, as no mention, only charge is written, we can find only magnitude. If mass are given, then only we can say whether it is attraction or repulsion. If in this case no value of charge given, we will identify. As written minimum, now look at force depends on charges as well as distance. Distance 1 meter fixed given, so we don't have any option to sense the distance. Only option is we can select the charge properly. So how to select the charge? Yeah? We know least possible charge in an object is that of an electron. Because if you look at an atom, in the very first class we discussed, total number of proton and electron is same. So in that way it is neutral. But if you remove one electron, it develops a charge. If you add 2 electron, it develops greater charge. So least possible charge is that of an electron. So value of charge here or value of charge here indirectly given. So what is the minimum force? 1 by 4 pi epsilon naught. Its value we can write. Its value will be 9 into 10 to the power 9. Q1, Q2 is 1.6 into 10 to the power minus 19, both same, so square, distance 1 meter, so square. So in SI unit, the force between them is this. Now look at, in all my previous question, only 1 by 4 pi epsilon naught written, and here I am writing 9 into 10 to the power 9. Actually, it depends on the given things in the question. If in the question information of charge is not there, only symbol given, then we should use only symbol for 1 by 4 pi epsilon naught. If by chance directly or indirectly value of charge given with distance, then we will put the value of this constant. That constant 1 by 4 pi epsilon naught is 9 into 10 to the power 9. I hope you understand the idea. Yeah, you have to come with some more example in the next class. Thank you.